When graphing two variable inequalities, the solution is going to be displayed as a region that will be shaded or colored in some way. The steps for graphing a two variable inequality are to transform the equation into slope-intercept form. That means y equals mx plus b. Except since we're working with inequalities, this equal sign would be an inequality symbol. So less than, greater than, less than or equal to, greater than or equal to. And when we're solving inequalities, it's important to remember to flip the inequality sign whenever we divide by a negative number or if we were to multiply by a negative number. Then we're going to graph the line. We'll either get a solid or dashed line, and that depends on the type of inequality symbol. So if the type of inequality symbol is either y greater than or equal to or y less than or equal to, then we have a solid line, just a regular line. But if we have y greater than or y less than with no line underneath, then we draw a dashed line. And this solid versus dashed line tells us whether or not the line is included in the solution area. So the solid line means that the line is included, the dashed line means that the actual line is not included. Then we're going to shade the correct region after we draw the line. Y greater than or equal to, we're going to shade above the line. Y less than or equal to, we'll shade below the line. Y greater than, we'll shade above. And y less than, we'll shade below. Another way to determine the shading is to test a point that's not on the line into the inequality, and if it works, then we shade the area with that point. If it does not work, we shade the opposite side. So let's do an example. Example 1, graph y less than negative 4x plus 6. We start with the y-intercept, since this is already in slope-intercept form, which is 6, and the slope is negative 4. So we go down 4 to the right 1 in order to draw a line with negative slope of 4. Now, since this inequality is less than, that means we have a dashed line through these points. And since it's less than, we're going to shade below that line. So if you put your pencil on the line and go down, our shaded area, or our solution area for this example, is everything below the line. So instead of remembering above or below for the shading, we could also choose a point to test. So for example, this point 0, 0. And we would test it in the inequality, so plug in 0 for y and 0 for x. That would give 0 less than 6, which is true. Since it's true, we should have shaded the side that contained 0, 0, which we did. Example 2, let's graph 4x minus 2y less than or equal to 10. For this one, we do need to transform it into slope-intercept form. So to do that, we're going to move the x's first by subtracting them from both sides. We would get negative 2y is less than or equal to negative 4x plus 10. Then we divide by the coefficient in front of y, which is negative 2. So we divide each term by negative 2. Now, since we divided by a negative number, we need to flip the inequality. So now it's greater than or equal to. Y greater than or equal to negative 4 divided by negative 2 is positive 2. X. And 10 divided by negative 2 is negative 5. So y is greater than or equal to 2x minus 5. Now that it's in slope-intercept form, we graph it. Y-intercept is negative 5 and slope is 2, so up 2 over 1 to get a line with positive slope of 2. And since the inequality is greater than or equal to, that means we draw a solid line. Y greater than or equal to means we shade above the line. Or you can choose a point and test it. If it works, you shade the region, including that point.